for some of the mobile anion nutrients, and here I'm thinking about sulfate, sulfur and chloride, you'll see reference to the average profile concentration or the depth weighted mean. So I just want to concentrate on sulfate, sulfur now, because that's the nutrient of that pair of analytes. And so for sulfate, sulfur, there are calibrations for the amount of sulfur or the average sulfur 0 to 60 centimetres, which is fine. If you send away a 0 to 60 centimetre sample, you'll get an average, the reading that comes back for sulfate, sulfur will be the average. But more often than not, we'll be using multiple depth samples. Okay, in this case here, a 60 centimetre sample is taken, split into 0 to 10 and a 10 to 60, sent away to the lab, and we get two readings back. We get 5 milligrams per kilogram for the 0 to 10, and we get 10 milligrams per kilogram for the 10 to 60. So what's the average? Well, it's not 7.5, okay, because the weighting is down here. We've got 5 layers of 10 and 1 layer of 5. So you could say with 5 layers of 10 be 50 plus 5, 55 over 6 layers. But there is a formula for this, okay? So let's have a look at the formula. So we're talking about depth weighted mean or average profile concentration. It's the same thing. And the formula is the nutrient concentration in milligrams per kilogram. And notice here there's no bulk density involved. It's just we're just working out the average of from what the lab has sent us back and the depth that we took the sample to. That's all we want to know. Just the average sulfate sulfur concentration. Okay, for the example we gave there, the soil concentration was, for the 0 to 10 centimetre layer, was 5 by the sample depth, which was 10 centimetres over 10, plus soil concentration of the second layer was 10 milligrams per litre, 10 milligrams per kilogram, by the sample depth 2, which was 60, minus the sample depth 1, which is 10, over 10, right? And that's all over the total depth, which is 60, divided by 10. So that comes to 5 by 1 is 5, plus 10 by 60 minus 10 is 50 over 10 is 5, 5 times 10 is 50, divided by 60 over 10 is 6, equals 55 divided by 6, 6 nines are 54, 9.2, and this is milligrams per kilogram. We're still in milligrams per kilogram because we're working out the average of the milligrams per kilogram that the lab sent us back.